Hi, I'm Togglebit, professional pickup artist, life coach and psychic. Today, we're gonna talk about something that I find really interesting. No, not myself. We're gonna talk about slabs. Let's do it! Vectors are incredibly useful. I use them on a daily basis. Some of my best friends are vectors, but there is one situation where the vector is not particularly good. That's a situation when you would use something like a hash map, for instance. Why is the vector not particularly good? Well, imagine that you insert something in a vector and you refer to it by its index, just like you would refer to a value in a hash map by its key. However, if you remove one of the preceding values in the vector, now your index is pointing to the wrong thing. This is not how the slab works, even though the slab that we're going to implement is built on top of a vector. Instead, when you remove a value from the slab, we store the index that we used in the removal operation and we reuse that next time we want to do an insert. When we go to do an insert in the slab, we're going to check if there is an available index or not. If there is, we reuse it. If there isn't, then we're just going to allocate some more space. Okay, implementation time. Let's build this. All right, so let's get to the implementation. And the first thing we're going to have is the entry enum that dictates whether an entry inside the slab is occupied or not. And this is a very basic enum. We're going to store two variants, a vacant variant that holds an option of a usize, and that's an optional index into the slab, or it's an occupied value, right? Next up, we're going to create the slab itself. This is just going to be a vector of entries that are generic over T, and the next ID that tracks which is the next ID we're going to insert into if there is one, right? Then we can get to the implementation of this, and we can implement the new function, which is just going to produce a new instance of the slab. Very simple stuff, an empty vector, none for next ID, we're done. Then we get to the first of two complex functions. They're not complex, but they're more complex than the get function. Right? And we can start with the insert function. So the insert function is going to insert a new value into the slab, and it's going to return an index of where that value is. So unlike a hash map where you get the key and the value into the hash map, here you insert the value and you get the key back, right? So the first thing we're going to do is we're going to see if we have a next ID or not. So we match on that, we take that ID because we can't reuse it, right? If we have an ID, then we're going to grab the entry that is at that location, and that entry has to be vacant. If it isn't, we're going to panic because that means that something is wrong with our slab, right? Something is wrong in this code, and we don't have to bleed this out into the public API. So we know that we're going to be able to return a use size here or not, right? Next up, we are going to update our next ID with the one that's inside the vacant entry. This means that when we do removals, for instance, we get that shortly, but when we do removal, we're actually storing the next location is the last location we removed at, right? So if you remove 0 and then remove 1, the next that is going to be 1, and when you've used that, it's going to become 0. But then we'll see that when we get to the remove function, right? Now we're just going to swap the entry out for an occupied entry that contains the value. So we now just swap the memory out, and we can finally just return the index to the location of this value now. Now, if we don't have a next ID, if this returns none, then it's very, very simple. All we have to do is get the length of the inner vector. That's going to be the index of the value, push an occupied entry into the vector, return the index, and we're done, right? Okay, so that's the insert function. It's not too complicated. Then we're going to get to the remove function, right? The remove function is going to take an index of the value we're going to remove, and just like a remove function in a vector, we're going to return an instance of T. This means that if you try to remove a value that doesn't exist or is already vacant, it's going to panic. And that's kind of how the vector behaves as well, right? If you wanted this to not panic, if you wanted to be able to call remove with the same index multiple times, then of course you could have this return an option instead, right? So we're gonna create a vacant entry where we store the current next ID of the slab. And we're gonna set the next ID on the slab to be this index, right? We're gonna swap this out for the entry that is at that location, and we're gonna make sure that this entry is occupied. If it's not, then we're going to panic. But like I said before, you could just return none here and return an option t instead if you wanted to, right? Finally, we're going to set the next ID to the index that we passed in. Again, the last thing we remove is going to be the first slot we insert into. And then we're going to return the value, and that's it. Now, the get function is actually really simple. We're going to pass in an index, and we're going to return an option of t. So the first thing we're going to do is we're going to try to get the value from the vector. If it's a vacant value, we're going to return none. If it's occupied, we're going to return an option with that value, right? Or some with value, right? And that's it. All right, let's actually use this by adding a main function to this. So the first thing we're going to do is create a slab. Then we're going to insert two values into the slab. Then we can just do a debug print of the slab to see what this looks like. Then we can remove the first value and debug print the slab and have a look at what the next ID is now. And then finally, we can remove the second value, which means we removed all values, and just print the slab again. All right. And let's run this now and see what this looks like. As we can see here, there is no next ID after we've done the two insertions. In the second one, in the second print, where we've actually removed one value, we removed the first value, the next ID is now pointing to 0. And in the third print, we've removed the second ID, so the next ID is now pointing to 1. And when we go to use 1, we're going to get 0 as the next ID, right? Okay, hopefully that makes sense. Now, wasn't that just a bit too exciting? Now, if you like the feeling of being ignored, you should definitely comment down below. And please, don't forget to like and... oh yes,